Hey too, what's going on here? Alright, we on almost the last topic, logarithm. So that topic was created by just urgent requests. Okay, so right now I'm going to show you a brief explanation what logarithm is. So make sure you understand how exponents works. So basically exponents means a to the power of x. So make sure you know that. Make sure you also remember how a to the power of x works as the function, so how it looks like, and let's start doing out logarithms. All right, so first of all, I'll give you a brief definition of what log is. So simply it's inverse operation relating to exponents. Okay, so what I mean by saying that in inverse, simply we have specific function log a of number y, and that's going to be x. If you have a look here, we use the same y and x that we used before. So let's see, y is the function of x. So, and this a, some number, what is called the basis, right? That's the basis or base. And x is the power, okay? So we raise base as the number to the power of x, and how we get y. Okay, so this is inverse, and basically, as you remember how to express inverse function, we just simply need to make x as the subject of y. So in this case, how it works, we're just applying log to both parts. So log with the base a, we applying to standard exponent function, and what we'll have, we'll just apply log a y, and here we also make log a to the power x. Okay, so and what actually happens, so this x as the power goes before log, that's just by definition, and that's why log a y becomes simply x times log a. And using specific property log a becomes 1, and that simply means that this is 1. All right, so that's why we can get x equals to log ay. So that's why we proved that this is an inverse operation relating to, or like applying to, the exponents. Okay, but I think I'm pretty sure that is still probably way concept for you. Okay, so for this reason, I strongly recommend to understand like vice versa. I mean, you just simply use definition of what log is. So simply you saying that log with the base a of some number y, or of some variable y, if it equals to x, so you can say that this is specific number x, so that, and now you're looking, be careful, so you're looking at the bottom part. You take a as the base, raised to the power of x, so simply you do that, okay? And that means you basically get rid of the log of base a, you get rid of this log, and that's why only y left here, okay? So this is by definition of log. So this is by def of the log with the base a. So simply one more time, what do you actually need to do? So you just need to memorize this simple thing, that log with the base a of the number y, or of the variable y, is simply some number x, or some variable x, that you need to raise your base, okay, a to the power of x, in order to get y, So that's why you understand now, maybe from this point is much more clear, that y becomes a to the power of x. And actually, you can always how to convert this back to log. For example, you have an exponent, y equals a to the power of x. How to get back to the log? All right, so simply just put sort of like prefix log a into the both parts. All right, just apply log a to both parts, and that what actually you did. And from there you can figure out that log a y simply becomes x goes before, and you have log a, which is by definition is 1. So this yellow part is simply 1. And that's why you can easily come back to log with the base a of the number y, which is equal to x. So that process actually can goes back and forth. So from log a y x, you can get the exponent form, and actually you from an exponent form you can get back to log a, so basically to logarithmic form. All right, now let's do maybe some numerical examples so that make sure you understand how it works. All right, so first of all we'll take that, let's say we'll get 2 to the power of 5, well known as 32. Okay, so basically 2 multiply itself 5 times, that's how we can get 32. All right, this is an exponent form, right? This is an exponent form. How to get log form? You just simply need to apply log of the base 2 in this case, because you actually, let's compare what you have. You have the base 2, which is simply a, right? So this is simply a. You raise to the power of x. So for the first time, you probably just mark as according to the formula. This is the power of x, and the result is 32 is your y. So simply you have this form one more time. What actually you have a to the power of x equals y. Now we have an exponent form. That's simple, your exponent function, where a is 2, x as the power of 5, and y, the result of that, the resultant function is 32. Okay, so what actually you need to do? Just remember you need to apply with log a to both sides, right? In order to get logarithmic form. So from where we know that this is simply 1, and we'll get x coming in before. So that's why we'll get x times 1, this is 1, which is simply equal to log with the base a of y. Okay, just moving back to your parameters that you have, you simply can do that. X is 5 equals to log with the base 2, because a is 2, of the number 32. Okay, or if you don't want, so if you feel confident without any formula, you just simply can't do that as I started to do. So if you have an exponent form, make sure you're just simply apply log to both parts with the base of 2. So base of 2, log 2, and 2 to the power of 5, and here equals to log again with the base 2, number that you have here, 32. All right, and what we're gonna do, we just simply say that this 5 by a specific property, I'll tell you later why is it so. Right now we just need to make sure to understand techniques in order to get quick and fast at solving this sort of questions and problems. So 5 goes in before, then we stays with log 2 equals log 35. Okay, so this is 1, and that's why you will have log 32. Okay, so now let's do the reciprocal procedure, means inverse. Let's say you have this, and from where you need to get an exponent form. So we have log 32 equals to 5. Okay, so what we need to do, we just need to use definition of what log is, because log is in inverse operation applying to an exponent form. So you just simply need to do the following. Take a raised to the power of x, and then how you can get y. So in other words, you simply need to take 2 raised to the power of 5, and that's how you can get internal number 32. Okay, so now it's very quickly and fast. That's your exponent form. Okay, so that's how it works. Okay, so let's prove why. Let's try to prove. Let's do a little proof and prove why log a equals 1. Because before we always used to say that log 2, and if a number equals to the base, so the number a equals to the base, the result of that logarithm is simply 1. Alright, so let's do just by definition. It's very easy to prove. Let's do it by definition. Do by just simply def. By def. So what we need to do, we need to take the base, raise to the power of what stays on the right side of the equality, and we should get a. Okay? So that's why if we raise a to some power, let's say x, we don't know, right? We don't know that actually it's 1. We need to prove that. So we mark, let's say this is x. So we need to raise a to the power of x, and that's how we can get your number a. So a equals a to the power of x. So what to do next? Having two bases the same, you need to equate powers. But be careful, the power is not 0, the power is 1. So that's why 1 will be equal to x, and hence the resulting number of this operation is 1. Okay, so we recently proved one more time, log a is equal to 1. This simply is done by definition. Okay, so that's how it works, and actually this is the basics of log that you need to be confident with. So one more time, so logarithm is simply the reciprocal operation or reciprocal procedure if you compare it with what you have in exponent form. Okay, so you can always make exponent and can write that in the logarithmic form, and vice versa. If you have logarithmic form, you can always convert into an exponent. So guys, hope you like that, hope it was clear. So logarithm is actually for a GCSE level. Like, it's pretty tough because probably like it's sort of, actually it's, I must say that it's higher tier, it's extended GCSE, RGCSE, but actually you need to be confident with the powers, like with the exponents, and only then just move back to that video. All right, so hope you like that. Don't forget to subscribe and share your ideas. Maybe, you know, if it's like way concept, try maybe to like ask some question. I'll try to answer. Maybe you can always send in comments like specific examples, and I'll always try to do that within like, I don't know, depends on like my time, but actually I'm always online, and you can actually get my feedback very fast. All right, peace out.